In today's tutorial, we're going to discuss the anatomy of waves. We've been talking about waves and how they are rhythmic disturbances that carry energy, and it doesn't displace the matter if it's going through matter, so that's key to this. We're going to start off with the classic representation of a wave. Not all waves look the way I'm going to draw it today, but it's usually what we use in order for us to understand all the different parts of a wave. So it kind of looks like a rope that's being moved up and down like a snake. So we're going to go like this. And before I continue, I'm going to put here, if the rope was not moved, it would be in a straight line like this. So we would have that is what we call the resting position. So this part right here is resting. Let me change my marker since you can't see that one. Resting position. In other words, undisturbed medium. No energy is going through there. So we have the resting position. Now once the wave starts, as energy starts, the wave starts moving and it makes the medium move and vibrate or have its rhythmic disturbance. And we can identify different parts to this. The highest part up here is called a crest. And that's the highest point in which the medium is disturbed. We also have the lowest part, which is known as the trough. So that is the lowest point at which the wave carries the energy. So if we were to think this is water, this is the part we see on top, this is what happens on the bottom, above the surface of the water and the bottom of the water. Another part of the wave that we need to discuss is what we call the node, which is this point right here at which it goes back through its resting position. And then we have the antinodes, which would either be here at the trough, or it would be up here at the crest. Both of those are called antinodes. So now we have three different points. Well, the next one, what we're going to look at is going to be the amplitude. The amplitude is the spot at which, from the resting position up to the highest point in a crest. Again, this would also be a crest. We could also measure amplitude in terms of from the resting position down to the lowest part for the trough. So amplitude can either be measured here and here. Now amplitude is a way for us to identify how much energy is being carried, so that the displacement here is based on the amount of energy. So in terms of, let's say, sound waves, it would be how loud the sound is. In terms of light, it would be how bright the light is. So it measures the amount of energy that it has, or we could also call it in terms of power or strength. So we can actually put this down here, is determined by its strength. That'll give you a better idea of what that is, right? Now, we have also what we call a wavelength. And this is the tricky one. Exactly where we're going to identify what a wavelength is. Well, typically, we measure wavelength from the crest of one to the crest of another. And that is what we call the wavelength. Is this part right here. From the top of one wave to the top of the next. Now, personally, I like to measure it from the beginning of the wave at its resting position, go up to a crest, go down through a trough, and measure it down here at the bottom. This is another way we can also measure it. Depends on which way is easier for you to see. Personally, I think this one's easier, so this spot would be wavelength as well. from here to here. I see that easier than I see the tops because it's kind of hard to measure exactly where the highest point of that wave would be. And so here we have, like I said, the classic representation of a wave, and its parts would be from the resting position, no disturbance, to when as it starts to disturb, we have a crest, highest point, the trough, the lowest point. The amplitude is measuring the amount of strength, and then the wavelength is determined from the crest of one to the crest of the other, or the beginning of the crest of one all the way until the end of the trough of the trough following.